So let's start the session. Okay. We'll continue with some more basic Linux commands. Okay. Yesterday we were working on something called as text processing tools, right? And in text processing tools, I actually showed you various commands. Like the first command we discussed was the less command. Then we talked about something called as head, tail, grep command, and WC. Okay. Now today we'll start with another Linux command, which is also comes under the same category, which is used for processing the data present in a file. We call this command as the cut command. Cut command is used for cutting the data present in your file in column-wise manner. There is some data in column-wise manner you want to capture the data, then we can depend on the cut command of Linux. Okay. So see, I am connecting to the Linux server, which is running on my cloud. Yeah. Once I connect to the server, do you remember we were actually working on a particular file called /etc/password. I have taken this file as an example because, as I said, this file is present on every Linux machine. Okay. And this file has actually 7 columns of information. Now, what is the meaning of those 7 columns? When I'm teaching you user administration, I'll tell you, but the columns are separated by a colon. 7 columns are there. They are separated by a colon. Now, what I want to do is, I want to cut the data. See, this is what I want to do. Let's first open the file via less command. What I want to do is, I want to capture the first column information and the 7th column information. First column information and 7th column information. First column information and 7th column information from the file. So remaining 2 to 6 columns I want to ignore. Only the first column and the 7th column should be captured. Then this is what I will do. I will say cut -d. D stands for delimiter. Where do you want to cut? I want to cut wherever there is a colon. -F. F stands for fields, columns. Which columns you want? I want the first column and the 7th column. From which file? What is the name of the file? /etc/password. That's it. When I hit enter, you will notice that from the entire file, it captured only the first column information and the 7th column information from every line. The first column and 7th column. Now, if this is too much, let's create a simple file for our practice. I'll create a file called file1. Like what we did yesterday, I will store some tool names. Docker, Kubernetes, Git. Now I'll say GitLab, Ansible, Terraform, Jenkins, AWS, Azure, like this. Some component names we have given. Look at the file content once. Now, you can categorize this file as having 3 columns. The first column has the data, what? Docker, GitLab, and Jenkins. Second column has data, Kubernetes, Ansible, and AWS. And third column has Git, Terraform, and Azure. How are these columns separated by a space? In the previous file, the columns were separated by a colon. Here they are separated by a space. Let's say I want to capture the first column information. This is the first column information. And I want to capture the third column information from this file. Only first column and third column information. Then my cut command will look like this. Cut -d. Where do you want to cut? Wherever there is a space. Previous example, we were cutting where there was a colon. Now I am cutting where there is a space. -F. F stands for field, column. Which column you want? I want first column and third column. From which file you are working on? File1. That's it. Do you notice it's capturing only the first column and the third column information? D stands for? Delimiter. Delimiter in the sense, based on which criteria you want to cut. File access. Absolutely. If you're not in that directory, you have to give the path of the file. Currently, You are in which folder? /home/Azure user. Within that folder only you have the file called file1. So directly I gave that. But in the previous example, I was working on a file called as password file. Password file was present in which folder? etc. So I had to give the complete path. That's it. Okay. So cut command is helping you to cut the data and capture the data in a column-wise manner. Okay. Two examples I have shown you. In one example, we were cutting the data based on colons. And in the second example, we were cutting the data based on spaces. Anything you can use. Now, the next example I want to show you is a command called as sort. Sort command, as the name itself is telling you, is used for sorting the data. Okay, if you have some numerical data or something like that, you want to sort it, ascending order or something like that, we depend on the sort command. So let me create a file where I will store some numerical data. See, I am creating file 1. I am storing some data in the file. This is the data. So if you look at the file 1, I have some numbers like 4, 2, 8, 1. I want to sort the data. Tell me what is command sort, specify the name of the file. That's it. When I hit enter, you will notice that it shows you the data in a sorted order. Straightforward. Directly it is arranging in a ascending order. Is it really sorting? Let's check it. What I will do is I will add some more content to the file. We know that in cat command, double greater than is called append operator. It will add some data to the file. So for example, I am adding some numbers like this. These are the numbers I have added. Now, if you look at the original content of the file, you notice initially this was the data in the file, but now you have added 3 more numbers, 14, 68 and 45. Now I will give the same command, sort file1. See what is happening? Is it sorting the data? It is doing an alphabetical sort. Sort command does not understand that the data present in your file is numerical data. How are things arranged in your dictionary? First character, then it will go for the second character. So here also it is sorting based on the first character. చూడండి first character ప్రకారం చూస్తే you will see it is in sorted order. It is sorting based on the first character, like how things are arranged in a dictionary. If you want to perform a numerical sort, I have to give the command like this. I have to tell sort -n. -n when you give, now Linux understands that the data present in the file is numbers, numerical data, and it will do a numerical sort. Now you are getting the exact answer you people are expecting. 1, 2, 4, 8, 14, 45 and 68. Okay. Generally, the sorting always happens in ascending order. You want to reverse this, which means descending order. Bigger numbers should go to the top, smaller numbers should go to the bottom. Then along with n, you will use an option called as R. R is for reversing. N is for numerical sort, R is for reversing that numerical sort. Now what is happening? Bigger numbers are going to the top and smaller numbers are going to the bottom. Okay. Now again, one more time, let's quickly recall. We have seen a command yesterday called as less. The purpose of the less command is to see the data present in a file in a controlled manner. If you have a huge file, you want to see in a controlled manner, we depend on less command. Then I talked about another command called as head. It will capture the top lines. Similarly, we talked about a command called tail command. We discussed a command called as grep, which is extracting a word from a file. Then I mentioned another command called wc. Today we were working on cut command and what else? And sort command. Okay. Now all these commands are working on the data which is present in the file. They are rearranging the data according to your requirement. That is why we call these commands as text processing tools. Head, tail, grep, all these commands come under one classification. The common name that we give for all these commands is, we call them as text processing tools. Okay. Any doubts you have, you can ask me. Okay. Next. Yeah, please.
So if we have a string kind of numeric data, how to sort those one?
No, how can you call it as a string kind of numerical data? If a
like
string is
or
having,
alphanumeric.
it is considered as a string only. They think it's
Okay,
not called as
okay,
numeric, it is called as string only. The default behavior of sort command is to work on string-based data only. That is why we did not see the elements in a ascending order initially, because it was taking the first character into consideration. So default behavior of the sort command is to work on alphabetical data only. It thinks everything is alphabetical data. When you want to do a numerical analysis, then we are giving the hyphen n option and telling that please do a numerical sort. Combination of alphabets and numbers is also called as a string only. It's not called as number. It is still considered as a string only.
okay.
Fine. Let's move into the next command of Linux. Permissions. In a Linux machine, whenever a file is created, there are three categories of people who will access the file. Listen carefully. Three people will have access on the file. One is the owner of the file. When I say owner, you can consider this fellow is the one who created that file. Okay. This owner is also called in some documentations as user. Okay. The next one is the permissions that the group will have. And the last one is what we call as others. Owner, group, and others. See, for example, if I create a file, then what will happen? Sai will become the owner, and owner will have one kind of permissions on the file. I'm sharing that file with my students. My students will have group permissions. Anyone who does not fall under the category of Sai and students will be treated as others. They will have another set of permissions. So every file will have these three categories of permissions: owner, group, and others. Okay. Now, how do you actually, and these permissions are categorized into three types. One is called as R and read. What is the meaning of read permissions? They can open the file, they can see the content of the file, but they cannot modify the file. They can just read the content of the file. You can also have W. W means write. Write means they can modify the file, editing the file they can do, they can delete the file, all those things. And you have one more permission called X. X ante execute. If it is a program, they can execute the program and they'll get some output. R stands for read permissions. W stands for write or edit or delete permissions. X stands for executing a program and getting some output out of it. Okay. Now, if you give the command ls-l, you see there is a file called file1 and these are the permissions. How do you identify that? Yesterday I told you that ls-l will show you the metadata. Metadata ante what are the permissions, who created the file, when it is created, what is the size of the file, all that is called metadata. See this. If the first character is coming as a hyphen, you understand that it's a normal file. అక్కడ చూడండి ఫస్ట్ క్యారెక్టర్ ఏముంది hyphen, which means it's a normal file. If it is a folder, if it's a directory, the first character will come as D. See, let me create a directory. Now, after doing this, if I do ls-l, do you notice for dir1, what is the first character? D, which means it is a directory. It's a folder. You can go inside the folder and all that. Next, see this. Let's talk about the file one. The owner is having which permissions? Read and write. He does not have execute permissions. He can read the file. He can modify the file, but he cannot execute the program. Group is having which permissions? Read and write. No execute permissions. And others are having what permissions? Only read. They can just see the content of the file. They cannot modify the file. They cannot execute the file. Now, let's look at this one. Tell me, for the DAR1, owner is having what permissions? Read, write, and execute, which means he can read, he can modify, he can also execute it. Group is having what permissions? Read, write, and execute. Others are having what permissions? Read and execute. They don't have write permissions. Understanding? This is how you read the permissions. Whenever you give ls-l, the first character is a hyphen. You understand that it is a normal file. If the first character is coming as D, you understand that it is a directory. It's a folder. Okay. And then you have the different permissions which are given for each and every file. If you want to modify these permissions, Linux has provided a beautiful command which is called as chmod. Chmod is a command for changing the permissions. These permissions can be changed in two manners, two ways. One is you can change that in the alphabetic notation. You can change it in alphabetic notation. And the second way of changing the permissions is the numerical notation. I will show you both the ways. But if you are comfortable with numerical notation, no need to learn alphabetic. And if you are comfortable with alphabetic, you can simply ignore the numerical. They are just alternate ways. Whichever you are comfortable, you simply stick to one process. No need to learn both of them. Now, let's start with numerical notation. If you want to change the permission in a numerical notation, three numbers you have to remember. Read is denoted with a value called 4. Write is represented using a number 2. And execute is represented using a number 1. These three numbers you have to remember. Read is 4. Write is 2. Execute is 1. Now, let's say I want to give read, write, execute all permissions. Tell me what is the number I have to give? 7. 4 plus 2 plus 1. I want to give write and execute. What is the number? 3. I want to give read and write. What is the number? 6. I want to give read and execute. What is the number? 5. That's it. You just add those numbers according to your requirement and that will become the permissions of the file. Okay. Let me practically show you. Let us take this file 1 only. And on the file 1, I am saying chmod 750 on file 1. Tell me what it means. Read, write, execute for owner. Group is having 5. What is the meaning of 5? Read and execute. Others are having 0. No permissions. Others cannot read the file. They cannot write into the file. They cannot execute the file. On which file you are doing? File 1. Done. Now, if you look at the permissions, ls-l, do you notice the owner of the file is having all permissions, read, write, and execute. Group is having only read and execute, and others are having 0 permissions, nothing. Understanding? Okay. Now, let's create another file and try to practice this. Touch. I'm creating a file called file2. Now, ls-l we will do on file2. And now I'll give the command like this. chmod 123 on file2. Tell me what it means. Owner has only execute. Group has 2. What is the meaning of 2? Write. Others are having 3. What is the meaning of 3? Write and execute. Okay. Done. Now, if you say ls-l, do you notice owner is having only execute permissions on the file. Group is having only write permissions. Others are having the write and execute. Understanding? As simple as that. You just add the numbers according to your requirement. That will become the permissions. Let's take another example. File 3 I am creating. As of now, this is the permissions of the file 3. I'll give chmod 777 on file 3. What does that mean? All permissions for everyone. Owner is having read, write, execute. Group is having read, write, execute. Others also having read, write, execute. See, after doing this, do you see? Owner can do read, write, execute. Group can read, write, execute. And others also can perform read, write, and execute. I hope you people are understanding. Okay. That's it. You just add those numbers and that will become the permission. Now, I have a small question before I proceed forward. I said that read is given as 4, write was given as 2, and execute is given as 1. Depending on your requirement, you're just adding those numbers and you're getting the permissions. My question is, why do you think they have given the read value as 4? Why not 3? If it is 3, it's more easy to remember. Remembering 1, 2, 3 is more easy compared to remembering 1, 2, 4. Avuna kada? Why they give it as 1, 2, 4? Why not 1, 2, 3?
Oh, change execute can be 3, read is 3.
Execute is only 1. Absolutely. Understanding. If you want to give write and execute, what is the number you are giving? 3. Now you are telling read also is 3. How will Linux understand whether you are trying to give read permission or write and execute? So what they have done is they have given the numbers in such a way that whichever number you add, you always get a unique value. There is no chance of repetition. See, 4 plus 2 is 6. 4 plus 2 plus 1 is 7. 2 plus 1 is 3. 4 plus 1 is 5. Whichever number you are adding, you are always getting a unique value. That's how Linux is understanding what permissions have to be given. Okay. This is the numerical notation of giving the permissions. If you are comfortable with this numerical notation, I would say forget the next thing that I am teaching. Don't even worry about it. Any one process of changing the permissions we should know. The next process of changing the permissions is the alphabetic notation. In alphabetic notation, you need to remember owner of the file or user is represented using an alphabet U. U stands for user. Group is represented using G. And others are represented using O. O stands for others. Read is given via R. Write is represented using W. Execute is represented using X. Okay. Now, if you want to add permissions without disturbing the existing permissions, you want to add permissions, you use this operator plus. If you want to remove existing permissions, then we use an operator called minus. If you want to assign permissions, you give an operator called equal to. Assign and replace. Existing permissions should be replaced with some new permissions. Then we depend on equal to. These things we have to keep in mind if you want to work on the alphabetical notation. Okay. Now with this, I'll practically show you. Say this. I will create a file. I'll call this as file 4. Look at the permissions of the file 4. I will say chmod. For the user, I am giving execute permissions. For the group, I am removing write permissions, but adding execute permissions on a file called file 4. See what it means? User, I told you user means owner of the file. User key are giving plus X. User is already having read and write. Along with read and write, that fellow is now getting which permissions? Plus means add, adding new permissions. For the group, what you are doing? You are first saying remove write permissions. Minus means remove. Group is having which permissions? Read and write. From read and write, first of all, you are removing write permissions, but you are adding execute, which means group will be left with read permission and execute permissions. And I did not mention others permissions, which means others permissions will remain same. They will not be disturbed. So if you execute this command, the final output that you people are expecting is owner will have read, write and execute. Group will have read. They will not have write, but they will have execute. Others permissions are remaining same, undisturbed. This is what we are expecting after executing this command. Let's hit enter. ls-l you do. Do you notice the owner has which permissions? Read, write and execute. Group is having read and execute. Others are having only read permissions. Understanding? Okay. Let's take another file. Touch. I'm just creating multiple files to show you how it's working. Okay. ls-l we will do on this file 5. And now I will give the command like this. Chmod. For the user, I will say user equals to X. What is the meaning of equal to? Equal to replace. Replace. Currently, user is having what permissions? Read and write. That read and write will be removed and it will be replaced with execute. Equal to what? Replace. Whatever you are giving, that will replace the older permissions. Okay. For the group, I will say minus RW. Minus and remove. What permissions you are removing? Read and write. That fellow is having, group is having only read and write. That read and write you are removing, which means they will not have any permissions. And for others, I will say plus WX minus R. For others, you are giving read and write permissions, but you are removing, sorry. For others, you are giving write and execute. Plus ante add. You are adding write and execute, but you are removing what? Read permissions. On which file? File 5. Simple. Plus means add, minus means remove, nothing complex. Only thing is, as I said, you need to remember user ante U, group is G, others is O. For adding permissions, you are giving plus. For removing permissions, you are giving minus. For replacing permissions, you are giving equal to. Now, in this scenario, you are telling U is equals to X. Equal to means replace. User is already having read and write. That read and write will be gone and that fellow will be left only with execute permissions. For the group, you are giving what? Removing. Removing. Group is having read and write. You are removing that read and write, which means group will not have any permissions. And for others, what you are doing? You are adding write and execute, but you are removing the read permissions. So the final result that you people are expecting is, see, this is a regular file, no read permissions, no write permissions, but that fellow will have execute permissions. Group will not have any permissions. And in others, no read permissions, but they will have write and execute permissions. This is user permissions. This is group permissions, and these are the permissions of others. Okay, that's what we are expecting when we execute this command. Let's hit enter. And after doing that, ls-l, please see that currently the owner is having only execute permission. You notice group does not have any permissions. And when it comes to others, others don't have read permissions, they have write and execute.
In case we need the capital X.
No, it will not. These are case sensitive. You have to give it as it is. Okay. Read, write, and execute. They should be given in small case alphabets only. Linux commands are totally case sensitive. You cannot change it from uppercase to lowercase. What is given in what order, you have to use it in the same way. Okay. Okay. So this is the process of actually changing the permissions. Chmod command. As I told you, you are either using numerical format. In numerical format, I'm telling you need to remember three numbers. Read is 4, write is 2, execute is 1. Alphabetical format lo user is represented using U, group is G, others are O, read is R, write is W, execute is X. To add permissions plus, to remove permissions minus, to replace permissions equal to. Okay. Now, whichever format is comfortable, you stick to that. If you are comfortable with the numerical notation, don't waste time on the alphabetical part. Simply stick to the numerical notation. Okay. Now, in interviews, when you go, generally they ask you what is the default permission of a file. Whenever a file is created, what is the default permission? Let's check that. I'll just create a file right in front of you. I'll call this file as file 6. And if you do ls-l on file 6, what is the permission of the file? Can I call it as 664? Ante kada? Owner is having read and write. Read is 4, write is 2. Group is having read and write. Others are having read. So the default permission of a file is 664. And the default permission of a directory, if you create a directory, the default permission for a directory will be 775. Let's check that also. I think earlier we created a directory called dir1. Look at this dir1. What is the default permission of the directory? 775. Owner is having read, write, execute 7. Group is having read, write, execute 7. Others are having only read and execute. So if they are asking you in interviews, what is the default permission of a file? You need to tell the number 664. And for directory, the permission is 775. But there it does not end up. Things are more complicated. On a Linux machine, there are basically two types of users. We did not talk about this till now. I'm addressing this for the first time. Tomorrow we'll elaborate on this. There are two types of user. One user that you find on a Linux machine is called as the root user, and all other users are called as ordinary users. Root user means he is the one who has complete control on your Linux machine. That fellow can do anything. Okay, he's the owner of the Linux machine. Ordinary user means limited permissions. See, for example, you are working in Wipro, let's say, okay? The Wipro company, that owner of that company will have root user access. As employees, you people will have ordinary user access. You're understanding? Owner of the Linux machine who has complete control on everything, that fellow will have root access. Ordinary users will have limited permissions. How do you see which user is currently logged in? Linux uses a beautiful command called as who am I? Who am I simply tells you what is the username with which you logged in into the server. See, my username is what? Azure user. In your case, it could be something else. This is an ordinary user. How do you go into root account? To go into root account, this is the command we give. SU stands for switch user. You are switching into which user? Root. Because here I am the owner of this server, I can go wherever I want. But in your real time, you might not have permissions to go into the root account like this. See, after doing this, if you say, who am I? Who is the user now? Root user. Understanding? Now, why I'm actually showing this is, I'll elaborate on this in greater detail tomorrow. When the root user creates a file, okay, listen carefully. Earlier, we have done all as an ordinary user. When ordinary user is creating a file, the file is coming with 664 permission, directory is coming with 775. But if the root user creates the same file, it comes with 644 permission and directory will come with 755 permission. This we'll see in tomorrow's session more practically and we'll try to understand that. Okay. Generally, in your real time, you will not have access on the root account. You will execute as a ordinary user. But from interview perspective, if they are asking you what is the default permission for a file and directory, the question you need to ask is it for ordinary user or for root user? If it is for ordinary user, when an ordinary user like you and me create a file, it comes with 664 permission, directory comes with 775 permission. If a root user creates the same file, the file comes with 644. 620 read write for owner. Group is having only read. Others are having only read. And directory comes with 7. 7 means all for the owner. Group is having 5. Read and execute. Others are also having read and execute. Now, these permissions, default permissions in the background are actually controlled by a particular value on Linux, which is called as the umask value. Umask is a default parameter which controls the permissions of your files. When a user is creating a file, what should be the permissions? It is controlled by umask. The beautiful thing that you need to observe is whether it is a root user or an ordinary user, did you observe something? When a file is created, file does not have execute permissions. The ordinary user aina, root user aina, files don't have execute permissions. And this is one of the main reasons for the high level of security that you find in a Linux machine. See, every few days, we hear about some kind of virus attacks happening on Windows based machines. But on Linux machines, it doesn't happen that frequently. Very, very, very rarely you will find something happening. What is the reason? The reason is when a file is introduced into your Linux machine, let's say someone introduces a virus program, it will not have execute permissions. When execute permissions is not there, what it will do? అలా కూర్చుని ఉంటుంది. It will just sit like that. See, let's leave computer viruses. Let's talk about COVID virus. What happens? COVID virus, probably one virus gets into your nostrils and it affects your lungs. After going into the lungs, because of one virus, no one will die. What that virus will do, it will replicate. It will keep on creating more and more viruses to an extent where it blocks your respiration and all other biological features. And if only one virus is sitting in your body, nothing will happen. It will just wait like that. It can't do anything. When that virus is multiplying as millions and millions, then it is causing harm to your body. The same thing here also. If a virus program is introduced into the Linux server, it does not have execute permissions. When it does not execute, it will just sit like that. It can't do anything. You're understanding? So this is how they made the OS so secure and all that. Okay. Anyhow, about the root user and these permissions, we'll explore in greater detail in tomorrow's session. Okay. So I think this is sufficient for today. We'll wind up the class. Tomorrow we'll explore the other commands of Linux. Okay. Yeah. Thank you so much. Online students, you too can leave if you don't have any questions. Okay. We'll resume tomorrow.
Hi, sir. Good morning.
Yeah, please.
Sir, when you are start AWS part?
What is that?
AWS part. This is Azure,
Uh,
right? I
no, no,
need
this is
a
not. This is
AWS
not.
part.
This
That's
is
why I'm
not.
asking.
This is not Azure. This is not AWS. What we are learning is Linux. From Monday onwards, the actual DevOps classes will start. Currently, we are not learning AWS, we are not learning Azure, we are just learning Linux. I showed you how to create these Linux servers on all the clouds, AWS, Azure, and on the Google Cloud. And I said that you use whichever cloud you want, you can practice the basic Linux command. So currently, we are not working on the cloud, we are just understanding basic Linux commands. The AWS DevOps will start from Monday onwards.
Okay, okay. Sorry, sir.